Hello, happy people. This is Mr. Wilcox coming to you from my kitchen table. We've been talking a little bit about trig and reducing radicals, and so we've been talking about functions with angles. So today we're going to talk about another way to measure angles. Instead of measuring angles in degrees and looking at a circle as 360 degrees, we can measure an angle in radians. So here's what radian measure is. I'm going to pause here so you can pause the video. And when you've got this written in your notebook, go ahead and hit play again. So like I said, radian is just another way to measure an angle. And a radian is the measure of the angle with arc length r, starting on the positive x-axis. So we're going to start on the right side in that quadrant 1, and we're going to work our way from the x-axis all the way in a circle counterclockwise. And so the radian measure is based off the radius of a circle and how much of a circumference of the circle it is taking up. So let's find out more about radian measure. So again, I'm going to pause here for a second just so you can pause the video and write this in your notebook. And then when you are ready, hit play again. So we've known from geometry and before that the circumference of a circle is 2 times pi times the radius, so 2 pi r. And remember, if we're measuring in radians r, that means there are 2 pi radians in a circle. So if there's 360 degrees in a circle, because the circumference is 2 pi r, there are 2 pi radians in a circle. And so if we reduce that ratio of 360 degrees to 2 pi, it reduces down to 180 degrees is pi radians. So half a circle is pi radians, and that is going to be our conversion factor. So again, radians are measured by the radius, how many radii they are taking up. So there are 2 pi radians in a circle. So to convert from degrees to radians, we're going to take our degree measure times pi over 180 so that we can find our degrees and change it to radians. And to multiply from radians to degrees, we're going to multiply by 180 over pi. So our radians cancel out and we are left with degrees. So let's start with converting degrees to radians. So if I want to multiply 135 and get it to be in radians, I'm going to multiply by pi over 180. Because remember, there are 2 pi and 360 degrees, which reduces down to pi and 180 degrees. So if I do that, my 135 over 1 times pi over 180 gives me 135 pi over 180. And if I reduce that fraction, I am left with 3 pi over 4. So 135 degrees is 3 pi over 4 radians, and you don't have to write the word radians. There's really no label for radians like there is for degrees with the little circle. So 25 degrees, to change out the radians, we're going to do the same thing. We're going to multiply by pi over 180. And so 25 over 1 times pi over 180 gets me 25 pi over 180, which reduces down to 5 pi over 36. So 25 degrees is 5 pi over 36 radians. All right. All right, so let's change some radians back over to degrees. So if we multiplied by pi over 180, so that our degrees cancel out to get radians, when we have radians to degrees, we're going to multiply by 180 over pi, so that our pi's cancel out and we are left with degrees. So to change 5 pi over 4 radians to degrees, I'm going to multiply by 180 over pi. And if I do that, I'm going to take my pi's will cancel out. And if I take 5 times 180 and then divide it by 4, I am left with 225. And so that is 225 degrees. All right. Same with pi over 10. If I want to change that to degrees, I'm going to multiply by 180 over pi. My pi's will cancel out, and 180 divided by 10 leaves me with 18 degrees. So pi over 10 radians is the same as 18 degrees. So a radian just represents the number of radii that are taken up in a angle. And to change from degrees to radians, we multiply by pi over 180. And to change from radians to degrees, we multiply by 180 over pi. So I hope you're all happy. I hope you're all healthy. And I hope you all have a great